3-2, quadratic equations, functions, zeros, and models. Okay, so 3-1 was learning about imaginary numbers and complex numbers, because 3-2 is solving quadratics, and like you saw in the very first graph from 3-1, if a quadratic is above the x-axis, there's no real solution, there's imaginary solutions. So that's why we had to learn that first. The new part, the college level part of it, is now we're going to look at solving equations that are like to the 4th power, to the 8th power, to the 1/2 power, by reducing them to quadratic form. I've never seen that before. It's really cool. And of course, then we do have a couple of word problems to level it up. Okay, let's take some notes on the front. Do you remember the methods for solving quadratics? Any of them? One starts with an F. It's not 4 letters. Factoring. Thank you. What is it? The quadratic. All right, I'm going to go with, let's see, 3, 4. I'm going to put that one at the very end because that is the one that works every time, but it is not everybody's favorite, so we'll put it in the end. You can solve by factoring. You can solve by square roots. The square roots only works solving by square roots only works when the middle term, which is called the bx term, is gone. That's the only time you can solve by square roots. So square roots is nice and easy and short and sweet, but it doesn't work every time. You can, of course, solve by graphing. Go to your calculator, enter it in y equals, and then do second calc. The x-intercepts are the solutions. There is another method that you may or may not remember to solving. It is called completing the square. Do y'all remember that one? I don't teach it with a box.
You have to like bring it in. Is that
This is where you isolate the variables and you add b over 2a to both sides, and then you write it as a squared, and then you solve by square roots. I don't think there's a box. I'm trying to think if someone could teach that with a box. Sorry, I'm standing in the way. What? Huh? What do we normally? It was like so fast, you went to him, and then it just burned away. So it was. Yeah. You didn't even have time to say that because it happened so fast. Okay, so these are. I'm going to put recall. ... These are ways to solve quadratics. You need to master all of them. The good news is that we're going to refresh you on all of them, and then we're going to level it up. Meaning our answers are not always pretty. That's the leveled up aspect. It's can you handle this with ugly answers, right? Which is where most people tend to think they're wrong when the answer's ugly. Not when you're in college. A lot of answers are ugly. Okay. Let's go to the first slide. Mine does not look like that.
I think you may.
Oh, that's what I just wrote. That's what it was. I added that in. This is what we just wrote. So if you do need a reference like how to factor with pretty answers, you can go back to in your textbook R4 and R5. They do refresh you on factoring. If you need a, that's it. No, that's all. Okay, so on your paper, mine matches yours. Okay, I added that there so I didn't have to write it last year, and I've completely forgotten. Go to example 1, you have your example 1 says, I'm just going to write it since I don't know what's happening. 2x squared minus x equals 3, right? And then on your paper it says, here is a space to do the algebraic solution, and then here's a space for the graphical solution. That's the slide you're looking at, right?
Yeah.
Okay. Algebraically, look at what you have. You have an equation. What's the power? The highest power, the degree. It's a 2. That's a quadratic. Is the bx term in there? Bx term means the x to the first power. Is it in there? It is, which means we cannot solve by square roots, because if you come back to right here, you can only do square roots when that bx term is missing. Okay, so now what we're going to do then is get everything to one side and check and see if it will factor, because if you can master factoring, it's the fastest way to go, okay? So let's get everything to one side. That positive 3 is going to come left and become a negative 3. Now, let's refresh you on factoring. Here you go, crash course. Multiply a times c every time. I don't care if a is 1. Multiply it so that you'll just be in that habit. This little x that I draw is to just help you organize your numbers. 2 times negative 3 is negative 6. Right? Copy the b term right here. B term is negative 1. Now it's a guess and check. What numbers will multiply to give me negative 6 and add to give me negative 1?
3 and 2.
So 3 and 2. Now it's a sign game. Make the 3 negative. Now check it. Do those multiply to give me this? And I'm going to write above it. This was the product of A times, let me put a dot. This was A times C, and this down here was B. That's where that came from. So do they multiply to give me this? Yes. Do they add to give me this? Yes. Okay, so we're going to rewrite the middle term using these two numbers. So instead of having minus x, I'm going to write minus 3x plus 2x. So this becomes minus 3x plus 2x right there. See, that's the exact same. Then I'm going to bring the front down and the back down. And now I'm going to highlight that just so that you know where it came from. Now we have it in 4 terms. We're going to factor it by grouping. Or when we're doing this, I'll remind you of the fraction method. So factor this by grouping. Group the first 2 terms together and the last 2 terms together. Make sure these parentheses are touching. What's the GCF here? Just x, right? Now, divide an x out. Imagine to yourself, x times what would give me that? 2x minus 3. Double check it. Multiply it back in your head. X multiplied into this. Does it give me this? Then you did it right. Repeat. Pull this GCF out. Always copy that sign every time. Is there a GCF in 2x and 3? Just the 1, right? And 1 matters. You are going to write it. There's no GCF, so pull the 1 out. Divide a 1 out, which means nothing changes. And then you should notice these do what? These match. If they don't match, you did it wrong. Now looking at it, you have some crap plus some crap. What do they have in common? They have the 2x minus 3 in common, right? That's your new GCF. I'm going to pull that to the front. So it's like a factor. I'm pulling this factor to the front, 2x minus 3. Now, when I pick that up and I pull it to the front, I'd be left with x plus 1. So you've just taken a polynomial, you rewrote it into 4 terms, you pulled the GCFs out, then you had a new GCF, you pulled it out, and now you have a binomial times a binomial. And this is important because now we can say, notice that you have something times something equals 0. This means one of these things has to be the number 0. That's the only way to multiply 2 things together and get 0. So you just set them both equal to 0 and solve. Add 3, divide by 2, subtract 1. So the answers are 3/2 and -1. Now, in terms of graphing, this would be a quadratic opening what direction? Up, and it's going to cross where? -1. So we're going to have a cross there. It's going to cross over, and then I'm going to put +1 tick mark. 3/2 and +2. 3/2 is what as a decimal? 1.5. So that's going to cross right there. So we're just sketching our graph. This is what it looks like graphically. It's going to cross, excuse me, it's going to cross the x-axis at -1 and 1.5. Let me show you another method for factoring. I don't know if you're going to like it. You may like it. I like it if I'm doing something quick. I don't like it if I'm trying to kind of keep an order about my work because I think in a linear way with math. Find some space somewhere on your paper. Can I just erase the graphing part? We're still on this slide. Maybe go to the right of the big box. Okay, here's another technique that I learned from actually a student who learned it from another teacher. Factoring shortcut. Now, if you watch it and you like it, then practice it. If you don't like it, then ignore it, draw an X through it, and just come back to this. This is called factoring by the grouping method. This is the tried and true, works every time, but you've got to be good with keeping your paper like in order, you know what I mean? Writing it neatly. You got to be good with GCFs right here. Catching that GCF, setting it equal to 0 and solve. Okay, so the factoring shortcut. You're going to take your AX and then the number that you came up with right here, and then AX and the number, and you're going to write it over the GCF. You're going to do it twice. Just watch. What was my AX? 2x, right? Okay, what was one of the numbers? -3. Is there a GCF here? No, so you just write 1 because there's no GCF, right? All right, repeat. AX, what was it? 2x. What was my number? Plus 2. Is there a GCF here? The GCF is 2. What comes out of that? Like, divide the 2 out. X plus 1. Bam. Notice that those two binomials are right here. Right there. You see that? So that's a factoring shortcut, because you should be good at factoring, you should understand the process behind it, but now we need to be able to take it further. I don't want to lose you in this, and then not be able to take it further. So this is a shortcut. It's AX, and then whatever the number, you still have to do this part, whatever the number was you came up with, then you write the GCF, like pull a GCF out. In this case, there was none, so that meant it was done. Here, AX, and then the number, there is a GCF of 2. Factor it out, or divide it away, whatever you want to say, and then write what's left, and that's your binomial. Okay? Maybe? Yeah, it works every time. I taught y'all the fraction method. I would call that a fraction method. There was a different fraction method that I taught you. But it is very similar. It just puts the number in the bottom instead of, but yeah, it does work every time. What I don't like about it is it's in the side. Like you have to come over here and do this because it doesn't blend into all of this, and that bothers me, but that's not OCD. We'll try it again with another, well, here we go. We got this one. Let's practice.
I don't see those.
No. Hold on. Okay, so there's some practice problems. With factoring this number 2 practice problem, I ran out of room, so the final answers are actually down here. We did do the shortcut again to see how quick and efficient it works. I guess if you keep it in line with your work, it's okay, but it still bothers me that it's just kind of like a block, a thought. If you're not good with factoring, I need you to practice, okay? It's like a sport, and the only way you're going to get good at it is to do a couple of factoring problems. We don't have IXL anymore, so you could turn to, in your textbook, the just-in-time review in the front. I think it's review 4 and 5 have factoring, and they have the answers there, so you could practice a few, okay? Not in the county, they discontinued the use of it in the county. All right, this slide you do have, right?
Yes.
Okay, so I figured it out. I had made a different set of notes from a different textbook. This slide is to give you, the purpose here is to give you a visual. When you're solving these quadratics, sometimes there's an answer where you have 2 real solutions. Sometimes you have 1 real solution, and then sometimes you have no real solutions. You have imaginary answers. This is what it looks like. So I'm going to write really big, visual. This is a visual of the 3 different scenarios when you're solving quadratics. If it's crossing the x-axis in 2 places, then you have 2 real solutions, meaning 2 x-intercepts. If it is sitting on the x-axis, you have 1 real solution. If it is above the x-axis opening up, or if it's below the x-axis opening down, that means it's not crossing the x-axis. that means you have no real solutions. Instead, you have two imaginary solutions, which implies the words no real. You have no real, you have two imaginary instead. And that's because it's not touching the x-axis. And we're going to put a big old question mark right here to represent, like, hey, where's it crossing the x-axis? It's not. All right, this is an example of solving by square roots. By square roots. You will notice there is no bx term at all. The x to the first power term is non-existent, which is your clue, solve by square roots. To solve by square roots, you want to isolate the squared. Whatever is being squared, whether it's a variable or a binomial, you want to get it by itself. Let me add to that. Isolate the squared part. And I'm going to say part because I'll show you an example over here. Sometimes it's not a single x, sometimes it's a parentheses of a binomial. Once you isolate the squared part, then you're going to use the square root feature to solve. All right, so 2x squared minus 10 equals 0. What is being squared? The x is being squared. Now, the 2 is attached to it, so it's going to be moved last. The minus 10's got to go. So I'm going to add 10 to the right. Now I'm going to get the x squared by itself by dividing by 2. Now I have what's being squared by itself. Now I can take the square root of both sides. So square root, square root. Here's where a lot of people go wrong. The very next line, when you solve by square roots, the very next line, every time, after you have square rooted both sides, will generate a positive negative sign. Because, if you think about it, for example, I'm going to come over here, i.e., 3 times 3 is 9, right, y'all?
Yes.
Okay. What's negative 3 times negative 3? It's still 9. So if I take the square root of 9, how do I know which one it came from? I don't. So that's why this right here is so important, because you're saying, hey, I really don't know where that 5 came from, although it's ugly. But I do know for a fact that it came from either a positive or a negative. The nice thing about solving by square roots when you get ugly numbers is you're done. That's it. I can't do anything else. They don't want decimals because that would be inaccurate. They want the radical. They do want it in simplest radical form. You do have to recall back to yesterday's lesson. Like if that had been square root 8, we would need to break it into 4 times 2, and the square root of 4 is 2. So you would have to do that. I'm going to draw a line, and I'm going to say, what if, ... What if you had x minus 3 squared equals 16? And I said to solve that by square roots. Well, first of all, you might think, well, the bx term is in there. How are you going to solve by square roots? Well, it's just this binomial that's being squared, which means you could solve this by square roots. You could multiply it out and then try to factor it, but that would be like reaching over your head to scratch this here when you really could just go like that, right? So recognize that this is another way, another problem that you can solve by square roots. You need to get the binomial that's being squared by itself, which it is here. If there was a number in the front, you would divide it. Now I'm ready to square root both sides. So that would cancel, and I'd be left with x minus 3. The square root of 16 comes from two possible numbers. What are they? Positive or negative 4. Now you have two totally different equations, and to finish this, you would split it and say to yourself, okay, so one equation is x minus 3 equals 4, and the other equation is x minus 3 equals negative 4, and you would solve those. So in this case, x is 7 or negative 1. How's this teacher text me? We should just go over that. That lose you? Tell me, where did I lose you?
Well, no, I just had a question.
Yeah?
On the x equals positive or negative square root of 5,
Yeah?
if you ended up with like a number outside of the radical, would it go before or after the positive?
No, it'd still be positive, negative, whatever the number is, the radical, because it's still part of it, yeah. I know, it should cut off.
The positive negative thing is really just.
Well, it's because of this right here. All right, go back to this one. Ready?
No.
Go to the next one. I turn the air off.
I don't know how to do that.
This is solving by completing the square. This is going to be your least favorite. It is a like memorization, and I'm trying to think. In my math lab, I'm not really sure that they have a way of knowing that you solved by completing the square. Y'all with me on that? You get what I'm saying?
My favorite.
I'm double checking. But in my math lab, you could solve by the quadratic formula, and they would be none the wiser. But I do want you to at least see. There's a completing the square one, but the final answer is the answers, which you could have done in the quadratic formula. Yeah, it's 13 practice problems. Okay, one of them in the homework is completing the square. All right, so let's look at it. The purpose of completing the square. So let's go back to this right here. Look at this right here, this example that we wrote. This was a binomial being what? Squared. That's called a perfect square. Anything to the second power, you're generating a perfect square, right? And because that was a binomial squared, we were able to take the square root. Okay, so what I'm going to teach you is, what if I give you a polynomial that is not in the format of a binomial squared? I'm going to teach you how to manipulate that without changing the value of it and get it in this format, so then you can say, okay, I'm ready to take the square root. Does that make sense? Now, like I've already said, my math lab has no way of knowing that you're actually using this technique. But it is a neat technique to see once you understand the math behind it. It's neat to understand how you're manipulating it. Okay. First, vocab word. If I tell you to find the zeros of a function, I'm saying find the solutions. I'm saying solve it. That's a fancy way of saying solve it. Which means the f of x, which is your fancy y, has to be what value if I'm looking for where it's crossing the x-axis? The y has to be 0. So it means find the solutions when y equals 0. All right, so let's rewrite this. And I personally don't like the 0 to be on the left side, so I'm going to grab that and just move it over here. So this is x squared minus 6x minus 10 equals 0. We are completing the square here. The first step to completing the square is you need the variables on one side and any constants on the other. So I'm going to make a note right here. Step 1, variables equals number, or numbers. Actually, it's just a number, single. You should be able to combine them. So you need the variables on one side and a number on the other. So this is kind of like the only one that does that. All of the others, if you think about it, you're either getting the square term by itself, or like with quadratic formula, you're getting everything to one side. Here you're saying, okay, negative 10, I need you to go to the right. I need everything else to stay here, leave some space. I need negative 10 to go to the right, and it would become positive 10. Notice I left some space. That's because with equations, whatever you do to one side, you can do to the other, right? I'm fixing to add a number to the left side that is going to produce a polynomial that's perfect. I'm going to add a number to the left side that will make this polynomial become perfect, which means then I can write it as a binomial squared, and then I can solve by square roots. Okay? And then, of course, whatever I do to one side, I have to do over here as well. Now, where do you get what you're going to add? There's a shortcut. So the shortcut to this, I am not about to try and teach you the actual 9-step process. Yeah. It is 9 actual steps. The shortcut. The goal. Let me show you. Don't write this. This is the goal. X plus 3 squared. That means x plus 3 times x plus 3, right? Okay, multiplied out, that's x squared plus 6x plus 9. Does everybody agree? Okay. This is what we're trying to find. This is what we're trying to generate. To be able to write it like this. This is the goal. You with me? Okay. So I know that that little polynomial is going to a binomial squared. That's my goal. I'm trying to go in the reverse of this. Okay? Here's where the shortcut comes from. Copy the x, copy the sign, b over 2. What's b? 6. 6 over 2. Close parentheses squared. Equals, bring the 10 down. Add b over 2 squared. I'm going to highlight it and show you what was just done. Hold on. This was the new part.
Where did you get to?
That's the formula. That's the shortcut. It's b over 2 squared. This right here. I am gonna put 3. I need you to know where the 3 came from, because then someone's gonna say, where'd you get the 3? I need you to write 6 over 2, because I want you to remember the shortcut is b over 2. So the shortcut is parentheses, x. Oh, we already had cookies. No, sorry, I'm sorry. Sorry.
He didn't have enough.
Oh. I want you to write that the shortcut is, you're going to parentheses, copy the x, the sign, whatever the sign is, and then it's b over 2, close parentheses, squared. Then go to the other side of the equal sign, and you're going to put plus b over 2, close parentheses, squared. Because you have to balance it out, right?
So it's just real.
So once, the hardest part is getting from here to here. Let me make it up. This is tough. This is the toughest part, is getting from that line to that line. From here on out, now it's, what is 6 over 2? It's just 3, right? So I'm going to clean this up. This is x minus 3 squared equals, this would be 3 squared. 9 plus 10, 19.
So every time that we do a problem like this, we always.
You will literally have one of these in the homework. And yes, it does go over 2. And that's because when you're, come back over here to what our goal was, I think, what did I do? X plus 3. Like when you multiply this out, first times first, outer, inner, and then last. Every single time, because it was perfect, you get the same thing here, so it doubles. So if we're going in the reverse direction, we've got to have it. So that's why. But now, look at it. I know this is probably your least favorite. It's everybody's least favorite. Now, look at where we are compared to the one we practiced. You see how it's the same format now? Now I have something being squared, which means I can take the square root of both sides. I can take the square root of both sides. Now I love problems like this, because watch. This cancels, I'm left with x minus 3 equals, Miss Holcombe told me I better write plus or minus after I write square root. Can I take the square root of 19? You cannot, so you just write it. It should make your life easier, because you're just writing it. You don't have to clean it up, because it won't. And then now you just add 3 over here. Now in this case, you know, you asked earlier, that was if it came from the radical, right? Notice the minus 3 is on the other side, and I'm about to move it to this side. They are not like terms. So when this moves to right there, becomes positive, this just goes right after it, and I'm done. Told you, it is number 7 in the homework. And I am actually, I'm going to say, I don't want to show you, let's see, I don't want to show you this one, because A is not 1 here, and in the homework, A is 1, like in our example. So, let's practice this. Mark this one out. Just mark it out and write x squared plus 2x equals 63. I'll show you when A is not 1 another day. I feel like you should practice when A is 1 first, because when A is not 1, it does change things a little bit. At the very first step, you have to divide everything by A. And in that case, it's going to create a fraction. And then I'm going to lose some of y'all, because you just learned how to do it here. So there's There's no need to dive right into the deep end yet. Alright, we're going to solve this by completing the square, which means I need variables on the left, number on the right. It's already there, right? From here, I can go straight to my shortcut, right? My shortcut is I am creating a binomial squared. Bring the 63 down. Then come over here and draw a line just so you don't forget that whatever you're about to do on the left, you got to go to the right and do it too. Here's the shortcut. Copy the variable. Copy the sign. B over 2. Just write it. Don't simplify it. Just write it. Close parentheses squared. Then you come over here, add B over 2. Close parentheses squared. That's it. Now you just have to clean it up. What's 2 over 2? That's just 1. Alright, this is 1 squared, which is 1, plus 63, 64. Look how pretty. Now I can take the square root of both sides. What's the square root of 64? There it is. Don't forget the negative side of it. And now you have 2 pretty equations, so separate them and solve them. You got x plus 1 equals a pretty 8, and then you got x plus 1 equals a negative 8. Now, here's what's funny. See how pretty those numbers are? Right? If you've gone to y equals and entered that in y equals and done second calc solve for the zeros, you would have gotten the same answer. Well, you have to do second calc for both, where it's crossing the x-axis. Okay. Now let's talk about the quadratic formula, which is everybody's favorite. Everybody's favorite. The quadratic formula, I'm not expecting you to memorize it, although I had to. My math teacher sang it to the tune of Frere Jacques, and I am so pleased and excited to tell y'all I'm not doing that. Not doing it.
Oh, yeah.
Well, y'all can just truck on right down there to her room and say, Miss Gentry, will you sing for me? Oh, yeah, I could.
She gave us extra credit for it though. It's kind of nice.
Oh, we should do that.
Yeah, we had to sing it.
We were
I'm not singing to you.
I'll sing.
You know what? And I'm not offended. I'm okay with it. I still love you. Sang. They had to sing, like they sang it. They didn't stand up there and go negative b plus or minus square root.
No, there was she had an instrumental track and everything. You stood up there and sang it.
I will.
She had the
Do it.
background
Extra
music.
credit, I'm for real.
All right, well, we'll do that. We'll do that Monday.
Microphone. I'm serious.
We'll do that Monday. That's if Tennessee wins.
Hold up.
Tennessee wins. Y'all can come up here and sing the quadratic formula for extra credit.
I really want Tennessee to win, but I don't think they got it.
Huh? What?
Oh,
Oh no, you gotta do it up here.
Wait, so are you gonna be there?
No, I don't. It's worth it.
It's at Georgia, but like.
I don't like Sanford Stadium. I don't like walking by and being barked at. I'm sorry.
Isn't Tennessee's mascot a dog too, though?
And we don't bark at people. We don't bark at people. I'll have to show you something I found on Instagram. It's funny. All right, look right here. Shh. Okay, everybody has a way of teaching the quadratic formula, right? A lot of teachers just tell you to plug it all in and clean it up. When I was teaching in geometry, with kids who really, math was not their favorite. I had to come up with a different technique because they got lost in that formula. There's a lot of places to get lost. I think you can all agree. So I came up with a technique that I would love to trademark. Don't you dare let someone else tell you they came up with it. Here it is. Indulge me for one example. Let me show you one example of my technique. And if you like it, great. If you don't like it, go to the technique of just shoving it all in there and cleaning it up. Here's the technique that I use. Find b squared minus 4ac first. Now, you're going to hear me call this crap. Write it. I want you to write it. You're going to hear me say, find that crap first. Which is what I mean. You might remember this, maybe. I don't know. Find b squared minus 4ac first. Here's why. Notice where that is. That is the radicand. That's where I lost most of my kids that were struggling with this. It was always when you hit that radical. So we started finding the radicand, just the radicand. Notice there's no square root yet. We find that crap first, then plug it in. All right, so entertain me one time and see if you like it. All right. Remember, you need everything to one side, which basically means you need it to be equal to 0 before you can start. With the quadratic formula, you got to have everything to one side before you can label your A, B, and C. Now, let's refresh you on what the directions are asking here. It says solve this quadratic. Notice it says exact solutions and approximate solutions, rounded to 3 decimal places. Exact means they want no decimals, which means radical form. Approximate solutions to 3 decimal places, that means, okay, then you can just tell me what the decimals are. All right, so my example here, 3x squared plus 2x equals 7. I need to subtract the 7 over. So I've got 3x squared plus 2x minus 7 equals 0. All right, what's A? What's B? And what's C? Okay, we're going to find b squared minus 4ac first. For the love of all things holy, put b in parentheses when you square it, because if it's negative and you square it without parentheses, it's going to stay negative, and that's a no bueno. It's supposed to become positive. So in this case, b squared minus 4ac. Then you go to your calculator and you type that exactly. 2 squared minus 4 times 3 times negative 7. What do you get? You get 88. If the bell interrupts me like I did yesterday, I'm going to finish this problem. All right, I'm going to plug it in. Here we go. X equals negative, I'm going to make this really bold, negative b. The formula says negative b right there. So that means that b has a sign change. Plus or minus square root of that crap all over 2a. You see why plugging that crap in makes it a lot easier? Now, you should know where this is going, because you should see a factor of 4 in there. Come over here, tell yourself, recall, ... square root of 88. What perfect square goes into that? How many times? What's the square root of 4? So the square root of 88 is actually 2 root 22, right? So I'm going to rewrite that, but I'm going to put 2 root 22 instead. I'm coming over here. X equals negative b plus or minus 2 root 22 all over 6, correct? I feel like Billy Mays. But wait, there's more. The info mushroom. 2, 2, 6. Careful. I'm going to shade it in red. Don't you dare come in here and try and divide 2 out of that radical. I don't care how pretty it is. It's under the radical. You can't divide the 2 factor out of it. It's the 2 in front that you can divide the 2 away. And it has to be all 3. It's all or nothing. Every single piece, all 3 pieces, has to be divisible by it for you to actually do it. So it'd be negative 1 plus or minus 1 root 22 all over 3. And that's the answer. Now, I put on your paper right here, they want you to type them as 2 separate answers. One's plus, one's minus, and then they want you to type the decimals as 2 answers. Okay?